Okay, let's look at the Theorem 1, AA Similarity Criterion. Right, so it states this. If angle A is congruent to angle X and angle B is congruent to angle Y, then triangle ABC is similar to triangle XYZ. Right? So let's do that. So in order to establish the similarity, we have to show all three corresponding sets of angles are congruent, and the corresponding sides have the same ratio. Right? So let's do that. Right? So using Euclidean angle sum theorem, we know that the third angles are congruent, so we can get that. So this is angle C is congruent to angle Z. So that part is pretty simple. So we establish that. Right. Then we have to do these ratios. Right. So here's the construction. So let's say if AB is congruent to XY, segment XY, then we can use angle side angle to establish actually congruence, which is more than similarity. So let's just assume that they're a different length. So let's say without loss of generality, we assume that the xy is larger than AB, right? So if that's the case, we can always chop the longer one down a bit. So let's say around here, right? So I'm going to call it the B prime, right? So that it's going to have the same length as here. So this is same length there, right? Then we draw a parallel line through B prime to segment YZ, right? So we're going to construct a parallel line like this. Right, YZ. So have that. And let's call this point the C prime. So we have B prime C prime is parallel to YZ, right? Alright, then we try to use the so F property. So here is the F property. Right. Using the F property, since B prime C prime is parallel to segment YZ, we know that this is congruent to angle here. Right. Then we can establish actually a congruence between a triangle ABC and a triangle XB prime C prime. So I'm going to just call it up. So this guy is congruent to that guy. So we know that the BC is congruent to B prime C prime, and AC is congruent to XC prime right here. Right. So by construction, we know that segment B prime C prime is parallel to XZ. So we can use a side splitting theorem and its corollary to show that XB prime over XY is equal to XC prime over XZ is equal to B prime C prime over YZ, right? And set that equal to some constant K, positive constant K, right? But remember that the XB prime is congruent to AB, so this will give us AB over XY is equal to XC is congruent to AC, So you have AC over XZ is equal to B prime C prime is congruent to BC, so over YZ. This is equal to K. Right? So by multiplying by the denominators, you can get, so AB is equal to K times XY, K times XY, and AC is equal to K times XZ, and BC is equal to K times YZ. Right? Then we basically got everything we need. So AB is K times XY, so we got that. BC is K times YZ, we got that. And AC is equal to K times XC. Right, we got that. Right? So therefore, we know that the triangle ABC is similar to triangle XYZ. Right? So that's angle similarity criterion. Right? That's it. I hope that this was clear.